Okay, so does anybody here not speak German? Okay, one. Also, ich habe eine ganz neue Technologie zu schauen. Kennt jemand Google Glass? Google Glass? Ja, ja. Und ich habe eine neue Technologie von Google. Es heißt Google Stimme. Wenn ich spreche auf Englisch, dann sofort es übersetzt meine Stimme zu Deutsch. Und das ist, warum ich kann Deutsch sprechen jetzt. Aber wer allen weiß, dass Google Übersetzer ist nicht perfekt, so ich würde besser für alles die ganze Sprache auf Englisch machen. So my name's James Roper. I work for TypeSafe as a lead developer on Play Framework, and I'm very very grateful to be able to speak to you today. As you may have noticed, I do speak a little bit of German. I lived in Berlin for 1 year. I actually worked for about half of that time at StudiVZ, which is pretty much almost dead. Not my fault. Yeah, so we started at this company, we started using Play Framework the day Play 2.0 was released. And we started a new project on that day because actually the company that makes StudiVZ is also owned by Holtzbrink, which owns Nature Publishing Group, and so we started doing things for other parts of the company. And when I first started using Play Framework version 2.0 on the day it was released, it had a lot of room for improvement, which is how I came to get involved in the project and became very active in contributing pull requests and making and on the mailing list, and ended up getting a job with TypeSafe. And so today I'm actually giving two talks. The first is an introduction to Play Framework. Who here has used Play Framework before? Okay, so there might be you might have some new stuff here, but mostly this will probably not be that new for you, but don't worry, because the talk after that is an introduction to iteratives. Who here is comfortable using iteratives?
Comfortable?
So I think I should have something for everyone here. So I've titled this talk, All Work, No Play Doesn't Scale. And the thing is, I actually don't like doing a lot of work, and to me, writing slides is work. So without further ado, let me get onto my last slide. So, what is Play Framework? It's a web framework for writing Java or Scala applications, and I should point out we have both a first-class API for Java and a first-class API for Scala. It's not like, well, because it's on the JVM, you can use Java or you can use Scala. In most cases, one of them tends to suffer, but we actually have first-class APIs for both. I'm guessing most people here are more interested in the Scala API, but if you're at a company that you're struggling to introduce Scala to, we see a lot of people who start on the Java API and then move to the Scala API once they get comfortable. It also supports fast development loops. So if you're familiar with, say development on Tomcat, usually you make a change. You might hit if you've got integration with your IDE, you might hit a redeploy button and it redeploys. And if your application is really fast, it might restart in like 2 seconds, or if it's slow, it might restart in 2 hours. Play has fast development loops, so when you make a change and then you hit refresh in your browser, you'll see that change immediately. Play also supports asynchronous I/O, and it's asynchronous from the ground up. Of course, if you do blocking operations in your code, it won't be asynchronous. But apart from that, everything in Play is asynchronous. We don't use looks really anywhere apart from at startup. first-class support for the modern web. And what I mean by the modern web is technologies such as WebSockets and server-side events. So the modern kind of ways of doing things with push requests. Play supports these out of the box first class. They're not kind of add-ons where you get this other library that kind of attaches to the side of your servlet framework to kind of do this thing that doesn't work in some places. It's right out of the box first class. Also things like less CoffeeScript, Require.js, all those client-side technologies that are quite popular and absolutely necessary for doing front-end development, single-page apps and those sort of things. Play supports these out of the box. You don't need to worry about configuring or anything like that. And I should also point out that it has first-class support for JSON. It seems rather obvious, but you'll notice that things like the servlet framework has no concept of JSON, whereas with Play, JSON is right there. As a first-class citizen, it's very natural to talk JSON in Play. So as I said, this is my last slide. So what I'm going to get onto now is a live demo of writing a Play application. Now, has anybody heard of TypeSafe Activator? Got a few people. Anybody not heard of TypeSafe Activator? Okay. So for those that haven't, Activator is a tool for getting you started very quickly with type-safe technologies, including Play Framework. And what it comes with is it comes with a number of templates. And so I'm going to start by creating a new application with one of these templates. So I've typed Activator new, and I'm going to enter an application name called messages, and I've just got an exception which has never happened before.
Oh, you need a connection.
Okay, no, it's fine. It just couldn't connect to the internet, but it's got cache stuff. So I'm going to use a template called Play Mongo Knockout. So this is a template that demonstrates Play connecting to MongoDB, and it uses Knockout.js in the front end. So in the messages project, I'm now going to run Activator, and once SVT starts up and hopefully doesn't have any problems with accessing the internet, I'm then going to generate some IDE bindings for my project because I do like using IntelliJ IDE, and then I'm going to run my project. Okay, and then I'll start it up, and so it's going to take a little while to compile, and in the meantime I'll open up my project in IntelliJ. So you can see here I've got a few. Here's the app directory with all the source code. If you've used Ruby on Rails, actually you'll feel very familiar with this directory layout. And my application is now started. I might make that a bit bigger. So this application, it's just a demo application. It's very simple. It just lets you add messages and lets everyone view those messages. So I enter my message, I click Add Message, and there's my message. And one of the cool things about this sample app is if I open it in this browser over here, and I'll pull that across, click Add Message, click Add Message, you can see over this it appeared immediately. So we've got a very reactive app here. Everything that happens anywhere appears everywhere all at once. Now what we're going to do is I'm going to introduce you to the code of this application, and the way I'm going to introduce you to the code is by adding a few new features. So rather than just saying, you know, here's this code, here's that code, hopefully you'll get a feel of the code by seeing what it means to add a feature. So the first thing we're going to add to this application is an author field, because we want to know who wrote the message on our message board. So it's a single page app, so everything's in the index file. And you can see here this is my modal dialog. I'm using Bootstrap to get started very quickly with the layout. And I've got here my message field. I might pull this across just a bit so you can see more of the code there. So what we're looking at here is a Scala template. There's actually not much dynamic stuff here on the server side because it is a single page app and everything's done on the client side. You can see also things like these data bind attributes. That's a feature of Knockout.js and allows you, in this case, it's binding this message input field to a message field observable that I've got in Knockout. So I'm going to add an author field. And so you can see there's lots of auto-completion here. Actually, that's just templates that I've set up for IntelliJ so that you don't have to watch me bumbling around typing and getting it wrong. So I've added an author field very similar to the message field. And I also need to, as you can see, I've bound it to this message author field property in Knockout. So I'll go into our CoffeeScript code. Now you don't need to use CoffeeScript in Play Framework, but I'm just using it to show that it works. This pretty much works out of the box. You just add some CoffeeScript code and Play sees it and compiles it for you, and you can use it. So here's that messages field that the message was bound to, and I'm going to add the author field there, and so that will be bound to that. If we hit refresh in the browser, you should be able to click add message and you can see the author field. Of course, nothing is done with it yet. So I'm going to here, I've got my save message method which posts the message as JSON back to the server, and I'll just add the author field to that JSON as well. So it's now been sent to the server. What's the server going to do with it? So in Play we have things called actions, and actions kind of live in controller classes. So I've got this message controller here, which is where there's some code to get messages. We can see here a message form. Now Play has this, the reason why I've called it message form is because it's a data object that represents the form on the client side. We've also got a data object, message data object here, which is what I use to save it on the back end. You can see it's got an ID, which is a Beeson object ID, which is a MongoDB thing, and the message. And the difference between these two objects is this one has an ID because it cares about the ID, but when you're submitting a message, you don't have an ID yet because the server hasn't saved it. So that's why they're different. So I'm going to add my author field here to my message field, to my message class, and then I'll add a similar one here to my message form class. And of course, here's the thing where I create the message object from the form, and so I'll just pass that author field. So now that I've put that message form, put that author field in the message form and pass it to my message object, and because MongoDB is schemaless, I should be able to just save this to just create a new message object. Before I do that, I'm going to add a author field to the existing messages object. It's important to do, with MongoDB it's schemaless, so you could implement the code to support multiple schemas at one time, but I'm not bothering doing that today. I'm just doing the schema changes manually in the database as we go. So now, if I hit refresh, sometimes Scala can take a little while to compile. I click add message. Okay, hopefully we have an author now, but of course we haven't rendered it. So let's go back to our index template. Down here is the list of messages, and I'm going to, it's currently in a simple list item. I'll get rid of that and replace it with something that puts the author and the message. And so if we hit refresh, we should see that I've got my author there. Now, with this, that's not very pretty, so I'll update the style sheet. Now I'm using less, could use straight CSS, but I'm using less just because I can. That's the wrong one. So now I've got my message author field rendered nicely, and it should look pretty. Now, I'm going to take a short break here from, we've implemented our first feature. I'm going to take a short break here from actually showing you more code, and I'm going to show you a few of the features of the Play development environment. So obviously the most obvious one is that you hit refresh to deploy your changes in the browser. But there's a few other features. So let's say I'm in my less code here, and I'll put that should definitely be a compile error. If I hit refresh in the browser, you can see it comes up with that compile error. It shows what the problem is, it shows you the file. Probably would have been a little more interesting if I'd done it up here. Still doesn't like the location. So you can see Play gives you, when you do these hot refreshes, it gives you the information at the place that you were viewing at the time, rather than having to go back into a console and see what the error was. So we can see that the case for less. Let's also see the case for our Scala templates. If I put in something here, that's not going to compile because I don't have a variable called TEH. You can also see in our coffee script, if I were to put a closing brace there, so unmatched brace, and of course in our Scala code itself, if I put in something that won't compile there, you can see it can't find that symbol. So Play is actually a very productive environment, because when you have errors, in the place where you're going to be looking because you've hit refresh in your browser to view the code, to view the changes, you can see right there and then what the error is. Of course, you might not be working in a browser, you might be working on a REST API, that's also fine. You can always go to the console and you can see that error message is just there. Okay, so we've got our message board. We're going to add a feature that every single application needs today, and that is social. So if you can't like something, then it's not worth doing. So we're going to add a like button to our messages. So I'm going to start in the back end this time. We'll go to our message object, and like before, we'll just add our likes field. It's just a simple integer. Now this time, obviously when you submit a message form, you're not going to say, you shouldn't be able to say let's start with 10 likes, so we'll just initialize every new message to have 0 likes. While I'm at it, I'll also go to my database and add a likes field of 0 to every message. Now this, now that we've got it returned from our back end, we can go into our code here and render it. So I'm using a feature of Bootstrap here where you can actually just get icons, thumbs up icon, that's going to be the button for clicking to like it, and I also print the actual number of likes. And so if we hit refresh now, we can see our likes button, and let's make it look just a little bit nicer. Okay, so we've got our likes button. Of course, we haven't implemented the functionality to actually do anything if somebody clicks it. So let's do that now. So back in the back end again, I've got this message DAO, and it's talking to reactive Mongo. Now, who here has used MongoDB? So a few people. So those of you that haven't, MongoDB has things called collections. They're, I guess, like tables in a relational database, except unlike a table, which is just a collection of columns, which you have columns and rows, your documents in a MongoDB collection can be quite structured. They're not flat. Though in this presentation, most of the documents I'm using are indeed flat. So I'm going to add a new method in here. And it's going to be the like method. And we're going to pass in the ID of the message that we want to like. And then we're going to return a future of a boolean. And the boolean is going to be true if we found the message with that ID and liked it, or false if there was no message with that ID. Now you notice here that I'm returning a future. As I said earlier, Play is asynchronous and supports async I/O from the ground up. And the way I'm talking to MongoDB is using a driver called Reactive Mongo. So this is a completely asynchronous MongoDB driver. So when you do something that's going to do some I/O, and when you're asynchronous, you can't wait for that thing to happen. So if you want to return some sort of value, you can't return that immediately, you have to return a future of that value. So that's why I'm returning a future of boolean. So the first thing I'm going to do is I'm going to call the update method on the collection. And MongoDB's query language is actually JavaScript, so I'm passing in a query here, which is a JSON object that says the ID should be this ID. You'll notice there I'm using underscore ID. That's just the MongoDB, I guess it's a convention for IDs. They'll automatically index anything that's got an underscore ID and treat that as the ID of the collection. Now here is my update command. MongoDB supports atomic updates, and here I'm saying increment the likes field by 1. So that's nice, I don't actually have to load the message from the database. I can just say MongoDB update it by 1 and it will ensure that it happens atomically, that nothing is going to overwrite it. Okay, now this update call returns a future, if you can see that, of last error. Last error is a funny name, it's MongoDB terminology. Basically means the result of the last command. I don't know why they call it last error, because it could actually be not an error. But it's a future of a last error. And we want to return a future of a boolean, not a future of a last error. So does anybody know how to turn a future of one thing into a future of another? Map. So what map does is it says when I finish doing whatever I'm doing, so when the last error actually is available, then execute this callback and make whatever I return, the future that I return, be that value, be the value of that callback. So I'm calling map here. I'm going to use the partial function syntax for brevity. So if the last error is actually okay, then I'll simply return true if the number of documents I updated was 1. So remember, if this will be okay if it didn't find any documents. So I actually want to make sure that I did update 1 document, and in that case I'll return true, otherwise false. And the last thing is, if it was an error, then I'm just going to throw an exception. Futures actually capture exceptions, and eventually when you try to do something with them in the end, you can it will carry that exception through any maps or any flat maps that you do, and you'll be able to access it. So now I've written my like method in the DAO. Next thing I want to do is talk to it in my controller. So I'm going to write a controller method, like message. Now I'm using this, because I'm doing an asynchronous operation, I'm returning a future. I use action.async. Otherwise I just use a straight action. So I call my like method on a message DAO with the ID. You'll notice here that I've got an ID parameter. We'll see shortly how that gets to my action. And we know that this returns a future of Boolean, but the action.async actually wants a future of something called a simple result. So how do we turn a future of Boolean into a future of simple result? We map it. So we call map, and then if it's true, return no content, because we don't really have anything to say back, but we just know that it's successful. And otherwise, if it's false, then return not found, because we didn't find that message to like. So now we've got a few more things to do. We've written our action method. How does Play Framework actually get the action when a request comes in to go to that action method? The answer is in a routes file. If you've done any Rails development, you'll be familiar with routes files. So you can see here are all the routes defined for my application. And for my like, I'm going to make it a post request. And on the message/id/like. And you can see here I've got the colon ID. That means it's a path parameter. And so I can now call my like message and pass that ID that's been extracted out of the path. So there's my my route. Now there's one more thing that I'm going to do on the back end, and that is I'm going to expose this this method in a JavaScript reverse router. So, and you'll see that in a minute. So don't worry about it too much now. But these are all the methods that my JavaScript calls. So let's go into the CoffeeScript now. By the way, I might say JavaScript when I mean CoffeeScript. CoffeeScript is essentially JavaScript. It's just a nicer syntax that allows things like functions to be declared simply with this instead of having to write out function and stuff. So we're going to write a new method here. If I can remember the shortcut, called LikeMessage. Take a message as a parameter. Now we're going to make an AJAX call. And here is where I'm going to use my JavaScript reverse router. So you can see here I've got my JavaScript reverse router with, and I refer to my message controller and that like message method we just wrote. And then I'm going to pass in the ID. Now the nice thing about the reverse router is I don't have to worry about fragile URL building. The JavaScript reverse router actually handles that URL building for me. In fact, it also even knows which HTTP method to use. So it will know that this is a post request and make a post request instead of a GET request.
Do I have to use CoffeeScript for that feature?
No. Everything. I'm only using CoffeeScript to show that you can. Okay, so we've got our CoffeeScript code to call that. The last thing to do is to bind the button to like it to that method that we just wrote. And so you can see here data bind when you click call root.likeMessage. And so that's going to invoke my CoffeeScript code. And so now hopefully if I refresh my browser, I should be able to like a message. Now, of course, we haven't said what should happen to the UI when I actually click it. It's I've just clicked it 3 times. If I refresh, it's not appearing. So do we have any errors here? I always forget something when I give this presentation. Okay, I know what it was. I put the data binding on the value, not on the thumbs up icon. It helps to put it in the right place. Actually, we should. I click that, maybe that would work. Let's see. maybe not. Okay, but anyway, I've just fixed it. So there we go. It is working now. So it's not happy. I'm not seeing it update immediately, but I can click it. Now, as far as updating it immediately, we could like hack it and put in something in there to say when I click it, then update the number of likes on there. But then that would mean it wouldn't appear in this window immediately. And we want to be reactive. We want the user interface to update immediately when anyone does anything anywhere. So let me, yeah.
I have a question first. Could you go back to the script source, please?
Yep.
So this, what's the difference between, so in the save message function you have this at Ajax, and in the like message function you have self.ajax. What's the difference there?
I don't think there is a difference. Let's have a look.
Is this at CoffeeScript syntax or place?
Yeah.
Yes, at means is a shortcut for this.
Ah, I see.
And let me just check that. That actually, no, it doesn't work. So why doesn't it work? The reason why it's not working is because this is a callback. So I actually have said up here that self equals at. You've got to be very careful with this in JavaScript because it's often not what you expect that it will be.
But you can use the big arrow in CoffeeScript, right? So that it does the this in your function, the callback.
Which one? What is it?
The equal sign instead of the minus sign for the arrow.
Really?
Correct?
Like that?
Yes.
I've never actually
And
tried
if you
that.
then type at, it should reference
That's right.
the right self or this. As far as I remember, I'm not completely sure.
It's great when the presenter learns things.
There's no error.
There we go. So, we just all learned something about CoffeeScript.
Yeah, it's because it's a callback and it has its own context.
Cool. Okay, so let's get back to that. How do we make the browser update immediately? So what I've used when you're deploying. If you want everything to update immediately and you have multiple applications that are connected to multiple different nodes, because you probably, if you're doing anything at any scale, you probably don't have a single web node, then you need some way for them to communicate. And since I'm using MongoDB, I thought I'd just simply use MongoDB cat collections. So obviously you could use any sort of messaging technology that you wanted. You could use upper clustering or all sorts of different things to do this. But just to keep it simple, I'm using the MongoDB cat collections, which won't scale infinitely, but they're definitely good enough for this presentation. So I'll show you here, I've got this event DAO, and it has a publish method, and what it does is it puts an event into the cat collection, and then down here we have a stream enumerator, and I'm using the plugin API to hook into Play Startup. But the important thing here is mostly just this here. This code here just ensures that the cat collection exists, so not strictly necessary. It is necessary in my presentation because I'm starting from scratch, and so I don't really want to do all this ops top stuff to create my collections. So, but here is the method that I'm using to query it. So Play uses, I will talk about iteratives and enumerators later. Enumerators are just producers of information, of data, and so when you talk to a cat collection in Mongo with reactive Mongo, it returns an enumerator, and then you can broadcast that enumerator to many clients. So with my message DAO here, if I like something and it was successful, then I'm going to simply publish to my event DAO that like. And that's all I need to do on the back end with all the infrastructure I've got set up there. On the front end, a little bit more involved to make this change. So first thing that I need to do is I need to make sure that the field for all the likes is observable. So at the moment, when I load all the messages, I simply just put the data into the messages field that has been watched, but I need to make sure that each one of those messages in the data, each one of the like fields can be dynamically updated. So I'm going to write a method here that binds, that makes the likes field observable, and then for all those messages I'm going to call the bind message method. And also here's where I handle the push. And I'm going to also bind the like field there. So now that I've done that, I can write a new event listener. So when I receive a like event, now what I'm using here is the event source API, also known as server-sent events. It's actually part of the HTML5 spec, not supported in IE unfortunately, but hopefully will be someday. So with this, basically it lets you subscribe to events, it lets the server push DOM events to the client, and then you can subscribe to them like you would any other DOM events. So I can push a message event, I can push a like event.
So this uses WebSockets, right?
No, it's a different technology.
Okay.
It's server-sent. It's called server-sent events.
Okay. But you can also do this with WebSockets, right?
Absolutely. The server-sent. So with WebSockets, you would need to define your own kind of protocol on top of that handled how this is a message and fanning it out to the right thing. Whereas you can see I've got this is part of the provided by the browser, this event source, and then you can just call add event listener and the type of the event. If you look at the event, you can see here I've got an event, it's got a name which is the type of the event and then the data, and then here I've got these extractors that extract the ID out and extract the event name. One of the things about event IDs is if the browser does get disconnected, it sends a header saying the last ID I saw was this. So you can ensure you can have some sort of guaranteed delivery of your messages to the browser while it's connected, even if it gets disconnected. So I'll pass the message data. I'll then, which should just be the ID of the message that was liked. Now I'm going to search through each of the messages, and if I find one with a matching ID, then I'll increment the likes in it. So now that we've done that, let's see. I'll hit refresh there, I'll hit refresh here, and I'll like this, and you can see it updates in both windows. So, and that all still works. So, thank you for listening to my presentation. I'll go to the token kind of last slide. So we saw how Play can be used to create reactive apps. That is an Activator template that you can go and you can download Activator, you can create a new application with a template, and there's actually a tutorial built into it that walks through the code in a lot more depth than I did today, and also goes through all those steps that I just did then, so that you can implement those features yourself and get an understanding of how to do it.